Okay, so welcome to the most horrific question I've ever seen in my life. This is section 9.4, conditional probability, dependent events, and it's been combined with a histogram. Well, it's so tricky I decided to have a go with this one myself rather than just run the video and then just see where it goes. So this is really complicated. The histogram shows the time taken for customer calls to be answered at a call center. Two of these customers were chosen at random to answer a survey. Okay, now I've calculated using the frequency, density and the bar width, or the class width for each of these classes. I've worked out the number of people represented by all of these 5 little bars here. And I've shown it below. So from 0 to 2 got a width of 2 lots of 19, 38, so that's correct. Next one from 2 to 3, that's a bar width of 1 times 32 gives us 32. So I've worked all these out and found that I've got a total of 197 people who called the centre over that given time, and now we're going to survey just 2 of them. We're told to work out the probability that both these customers waited for more than 4 seconds. Well, more than 4 seconds, so what we actually need is a very thin slice of this bar right here. Very hard to get it to land, leave it there. So I want the people on this side plus the people on this side. Alright, so let's see how many we're talking about. If I enlarge that by drawing a little picture, I've got the little bar here, which say starts at 4 there and then goes to 5. Then I've got the wider bar, the fatter wider bar, that goes as far as 10 seconds. I know straight away that I've got 55 people in this last section. Put a 55 there, that'll be fine. That's 55 people, that represents that last part of the histogram. Now I've got a bar width of 1 there and a frequency density of 30, so I know that's 30 because I'm reading it off here. There's my 30 that matches that part of the bar there. So I've got 30 times 1, that represents another 30 people therefore. So we're looking at a total of 55 plus 30. We're looking at 85 people who took longer than 4 seconds to be answered. So what do we got here? The question says, what is the probability that both customers waited for more than 4 seconds? Well, first customer, we've got 85 over 197, and there's the total right there. And the other customer will be the remaining 84 who waited longer than 4 seconds out of the remaining 196 customers. Now I've calculated this and it simplifies down to 255 all over 1379. Okay, if you do that, you end up with a big number over an even bigger number. That does in fact simplify down. In fact, while I'm at it, I might as well just put it in decimal form. So 255 divided by 1379, it's going to give me 0.18. So 0.185. So leave it like that. So the probability that both these customers were kept waiting for more than 4 seconds, not such a long time really, is actually 0.185 or 255 over 1379. That's part A done. Now, next part, extremely complicated. Continuing with question 8, looking at 8A part 2 of question 8, page 136. Let's just go for a wonderful tree diagram again. It says, calculate the probability that one customer waited less than 4 seconds and another customer waited for more than 4 seconds. Well, a tree diagram is really helpful here. So here I go. We can wait greater than 4 seconds, or we can wait less than 4 seconds. That's customer 1's scenario. Oops, accidental marking there. Let's rub that a little bit out, it should not be there. Now that's customer number 1. The second customer can also wait more than 4 seconds or less than 4 seconds. It's customer 2. Or wait more than 4 seconds or less than 4 seconds, depending on what the other customer number 1 has done. That's that. Right, let's write the probabilities in because they're really tricky. Greater than 4 seconds. We know it's 85 over 197 from before. That leaves us with 112 over 197 for those who waited less than 4 seconds. Now, if we have 85 out of 197 waiting more than 4 seconds, to find another customer waiting more than 4 seconds, we have the remaining 84 out of the 196, which leaves me with 112 over 196 on the branch for those who waited less than 4 seconds. Again, over here, if you've got one who waited less than 4 seconds, 112 over 197, we have the remaining 85 who waited more than 4 seconds, as over here, but we're now down to 196 people. Likewise, 196 will be the denominator here, and 85 from 196 leaves us with 111. Now that's the chart all set up, ready to go. Sorry, the tree diagram. And the question says the probability of finding one customer who's less than 4 seconds and the other one greater than 4. So these are the options. I will go greater than 4 followed by less than 4, or less than 4 followed by greater than 4. So I don't need that branch, and I don't need this bottom branch here. I just need to work out the two probabilities here. Alright, so I'm looking at 85 over 197 followed by those who waited less than 4 seconds, 112 over 196. That gave me an answer of 340 over 1379. No worrying about simplifying just yet. And over this branch we got 112 over 197 followed by 85 over 196, and as you can see that gives exactly the same answers because these have just been flipped round, and that will give us another 340 all over 1379. Get the total there. We've got 680 all over 1379, and that is approximately 0.49 as decimals, or you can just leave it like that if you want to. So the probability that one customer waits for longer than 4 seconds or the other one waits less than 4 seconds is 680 over 1379, approximately 0.49 to 2 decimal places. Alright, now here's the last little bit of it, part B. Part B says, given that both customers actually had to wait under 3 seconds, what is the probability that they both had to wait under 2 seconds? Alright, so let's look at all the people who waited for under 3 seconds first. Where are we? Right, under 3 seconds. I have here 38 people plus 32 people. I have 70 people for whom this part of the question is relevant. So let's flick on. Right, I've got 70 people. Do it in big bold red. Now, out of those 70 people, I have 38 who waited under 2 seconds. Let's just flick back and be absolutely sure that's true. Right, there they go. I've got 38 who waited under 2 seconds. Alright, so the story is we've got, let's just mark this up then. This is where we're heading at the moment. We've got 70 people, and these 38 waited under 2 seconds. In fact, it says, given that both customers actually had to wait under 3 seconds, what is the probability that they were both in this first class here and actually waited under 2 seconds? So, back to the question at hand. Right, out of 70 then, well, the first batch of 38 people are those who waited under 2 seconds. That's the first customer. Now the second customer, if he's taken out of the equation, we're down to 69 customers, and if 38 waited under 2 seconds, then we're looking for him to be amongst the remaining 37, and that's quite easy really. That will give us 703 all over 2415, because I worked it out earlier. That's approximately 0.29 seconds, a very, very short wait. And that is the end of the hardest question I think I've ever done in my life.